Hello class, welcome to Geometry 3-4, which is all about the classification of rigid motions. By the end of this lesson, you should be able to identify different rigid motions used to transform two-dimensional shapes. So Theorem 3.3 states that the composition of two or more rigid motions is also a rigid motion. So that means if I were to reflect an image and then translate it, that reflected and translated image should still have the same size, same shape, all of the lengths and angles are preserved, okay? So let's start with example 1 and explore some glide reflections. So if we look at the graph on the right, we have triangle ABC and triangle A prime, B prime, C prime. So we started with the black triangle and we moved to the red triangle. We want to know, is there a rigid motion that maps triangle ABC to triangle A prime, B prime, C prime? So if we look at that, let's think about the types of rigid motions that we've worked with so far this chapter. We've worked with reflections. Is that a reflection between those two? No. Is it a translation where it just slid over somewhere on the graph? No, because the orientation, the way it faces, has changed, right? And the last one that we talked about was rotations. Did that rotate? No. So that means that there's no rigid motion that moves that first triangle to the second one. So then let's look at letter B. That's essentially what I just asked. Sorry. Let's move to letter C. What composition of two rigid motions maps triangle ABC to triangle A prime, B prime, C prime? So if we look at that, I could see that triangle ABC has been flipped because A used to be on the left of the triangle and now it's on the right. So I need to figure out, there's going to be a reflection in there somewhere. And then it's also moved down. So it's probably a reflection and a translation. So if I reflected this triangle, it would look something like this. So that way I could move it straight down in order to get to my final image. But I have to figure out what line it reflects over. So if I look, what's my distance between B and then the second B, I guess, that I have there? There's 4 units between them. So if I were to cut that in half, let's see if that cuts everything in half. So C is also 1, 2, 3, 4 away, and A is 1, 2, 3, 4, 1, 2, 3, 4. So we can see that that vertical line is our line of reflection. So we want to figure out what that equation is for that line. Hopefully you remember how to write an equation for a vertical line, but I know that this is something that you guys often seem to forget. So if I look at that vertical line, what is my x value at that vertical line? It's x equals -1. And if I go right here, my point is -1, 0. If I go down 1, it's -1, -1. If I go down another one, it's still -1, but now -2. I could also go in the positive direction. I could say -1, +1, or -1, +2. But no matter what, notice that my x always equals -1. So my equation for a vertical line is x equals -1. And now we have to figure out what that translation is that moves it. So then how far does C have to move in order to get to C prime? It moves 1, 2, 3, 4, 5. It went down 5 units, so I translated it. Did I move it left or right? No, so I'm going to put a 0, and then I'm going to put a -5. So those are the two items the two rigid motions, But how would I write them as a composition? So remember, this is where we use that kind of open dot and we list the two rigid motions, and the one that we do first is the one that we list last. So the first thing that we did was we reflected, right? So I'm going to say reflect, that's the capital R. Then I'm going to say x equals -1. And then after we've reflected, I'm going to translate it, and that's where I write my 0, -5. So this would be the composition, except I forgot one last thing, and that's to do what image you are translating. So that is how you write a composition of two rigid motions. Sometimes working backwards helps, or looking to see how can you get a figure to face the same way. Let's look at finding the image of the glide reflection here. So we have a digital artist is reproducing a tire thread pattern from a partial tire print from a crime scene by applying a glide reflection. She uses the rule translate 0, 0.1 composed with the reflection over the y-axis to generate a pattern. Confirm that her rule can be applied to the partial pattern that was taken from the crime scene. So if we look over on the right-hand side here, we have these tire tracks, right? And if we want to figure out how to get this kind of staggered pattern, it might be tough to see on this picture, but the pattern goes something like this, and she wants to replicate it. So if she were to draw an X and Y axis, and we start with these two, you can see that that pattern doesn't match this where they're staggered, right? So I need to adjust that. So first, if we reflect it over the y-axis, that would be this right here, right? If we started with this and reflected it over the y-axis, we would end up with something right there. But we don't want them to be at the same level. So if I start with this, I reflect it, and then I translate it up in order to get that staggered pattern. So that is why we would write the rule, reflect over the y-axis first, and then translate, and that pattern will continue to work for the crime scene. So I just realized I forgot to include Theorem 3.4, which just states that any rigid motion is either going to be a translation, a reflection, a rotation, or a glide reflection, okay? Those are the 4 types of rigid motion. Okay, that means that those are the 4 types, or the 4 ways that we can move an image and have it stay the same without changing size or anything, okay? So those 4 ways, again, were translation, reflection, rotation, or glide reflection. And you can check that out in your book. It's Theorem 3.4. And so let's look at this last example. We want to determine any glide reflections. So we want to figure out what is the glide reflection that maps triangle JKL to triangle J double prime, K double prime, and L double prime. Okay, so that double prime tells me that it's moved twice. Okay, so we're going again from the black triangle to the red triangle, and we want to figure out what composition, so what 2 rigid motions are put together to make this single motion happen. So if we look, I see that my red triangle is flipped upside down in comparison to what it was. So I know there's going to be a reflection somewhere, and it slid over. So there's probably a translation somewhere as well. So let's start by maybe let's move this triangle back over so J and L are lined up with J double prime and L double prime. So if I move J 1, 2, 3, 4, 5 units, you can see that it now lines up nicely with J until I moved that graph. Whoops. All right, so I'm going to move it 5 units to the left, so that would be a -5 if I'm writing a translation, right? And then I didn't move it up or down, so I'm going to put a 0. So this becomes, let's call this J prime. Then if I move L 5 units, it'd be 1, 2, 3, 4, 5. I want to make sure that that stayed the same number of units as L, or as the J movement did. And you can see that it lines up with L down below. So I'm going to call this L prime, and I'm going to move K 5 units as well. 1, 2. So here's K prime. So if I am trying to figure out now, that was a terrible line, sorry guys. If I'm trying to figure out now how to make that J prime, L prime, K prime, how to get that back to just JLK, remember, I need to reflect that over something so that way it flips again. So let's figure out how far apart are J and L. They're J and J prime. 1, 2, 3, 4, 5, 6 units apart. That means halfway would be 3, right? 1, 2, 3. Let's make sure that L, 1, 2, 3, 4, 5, 6, the halfway would be there. K is 1, 2, 3, 4 away, so halfway would be that point right there. So if I were to reflect over this terribly drawn line, because my smartboard's freaking out, that would be my line of reflection. And how do we write the equation for a line that is horizontal? We say y equals, and in this case, our value of y there is 1. So I'm going to do a composition. Which one did I need to do first? If I were to go from JLK to J double prime, L double prime, K double prime, I would end up having to reflect it first. So I'm going to say the reflection, so capital R, over y equals 1. And then I'm going to translate it -5, 0. And this is the triangle JKL. And that is my composition between those two images, the black triangle and the red triangle. Okay, so I recommend start with the image, so the red triangle, and work your way backwards to get to that black triangle that you started with. All right, and here's a nice little concept summary to help you keep track of all of these types of rigid motions. So we have those reflections, rotations, translations, and then our glide reflections, okay? If you have any questions at all, please feel free to reach out to myself or a friend, and have a fantastic day.